All right, today we're doing 13.2 notes, so you have two objectives. You're going to draw and calculate angles, and you're going to convert angle measures between degrees and radians. So radians will be something a little new. It's not a difficult thing. As long as you know pi over 180 or 180 over pi, you're going to be just fine. Today's date is the 12th. Is it? Yeah. Sweet. Ladies and gentlemen, that's Ben Prochniak. Shh, just right. Two things that you guys should have talked about on Monday, right? You guys got all the notes on Monday? Okay. On Monday, first thing is, main thing to remember is what word? What was it? SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, opposite over adjacent. If you guys can remember that, you're set. And then the table that you guys filled in, the values, if you can just remember that first column, sine of 30 is 1/2, sine of 45 is root 2 over 2, and then sine of 60 is, anybody remember? Root 3 over 2. Right? Pretty sure that's what it is. If you guys remember those three values, then you can fill in the rest of that table. Because for those, you're not going to have a calculator on the test, so you have to know just some of those basic ones. And if you can't remember, you just draw the triangle in. And like I said, the next couple of days I can show you how to remember those triangles. But for today, we're just going to do 13.2. There's three things you have to write down. Let me move this a little bit here. Standard position of an angle, and it's actually just, it'll be common sense once you see when we draw it. Measure of an angle. So when we're measuring an angle, we can measure it in positive degrees or negative degrees. Or when we get to later in the section, it'll be positive radians or negative radians. And then we'll talk about coterminal angles. Standard position of an angle is the position of an angle whose vertex is at the origin, whose initial side is the positive x-axis. And what I mean by that is, bless you, when you guys draw angles, if I just take a look at real quick. Thank you. The initial side is the positive x-axis. So when we start an angle, we're just looking right here. It's just on the x-axis. And then we call the terminal side. We're going to make the angle. So if I draw this, here is my angle in standard position. Standard position just means that you always start on the x-axis, and then 98% of the time, I would say, if I just ask you to draw an angle, you're going to always rotate counterclockwise, and we'll talk about that when we get to the positive and the negative. That means something specific. But normally you're going to rotate counterclockwise to figure out what degree that measures, because usually we don't do negative degrees when we talk about angles. We always do positive, but we will talk about positive and negative because it can happen. So a positive angle, again, if I start with my initial side just on the x-axis, a positive angle is always measured counterclockwise. So if I want to draw an angle, that would be a positive, and if we estimated, well, there's 90 and another 45, so maybe that's a 135 degree angle there. It's a positive 135 because you're rotating counterclockwise. A negative angle, all that means is you're going to rotate counterclockwise. Still start in the same spot. There's my initial side. And now if I rotate, when I rotate clockwise, that's a negative measure. So on this one, if I go 180 degrees and then another 45, that would put me at what angle? A negative 225. 180 plus 45. If you notice these two pictures, my terminal side is in the exact same spot. And that's what a coterminal angle represents. A 135 degree angle means you rotate counterclockwise 135 degrees. A negative 225 degree angle means you rotate clockwise 225 degrees. And notice where those terminal sides end. They end in the same spot. That means that they're coterminal angles. When we start doing some trig with all that, it's the same thing. What you do is you get a reference angle. So you always figure out, well, how far is it from my terminal side to the x-axis? In this case, it's 45 degrees. So that's your reference angle. You always are going to go back to the 30 degrees, the 45 degrees, the 60 degrees. And then on your calculator part of the test, it'll be anything. Like it could be a 61 degree angle or a 23 degree angle. For those, then you're going to have to use your calculator because we don't have just the special cases for them. So terminal side, if it's in the same spot, they are coterminal angles. Again, this was a positive 135. This was a negative 225. If I added those two together, I should say the absolute value of those two together. What's 225 plus 135? 360. How many degrees are in an entire circle? 360. For those of you that play Nintendo games, if you remember for Nintendo 64, there's an old game called 1080 Snowboarding. 1080 snowboarding meant 3 complete revolutions. 1080 degrees is 3 complete spins. And now they probably even go farther than that. I don't. I have trouble just going once around. So, 135, negative 225, they're coterminal, same angles. You guys are going to list a bunch of them. Jess. The initial side is the one that's on. So you're always going to start on the x-axis, that's your initial, and then wherever you draw your line after that, that's your terminal side. Because that's where basically the angle ends. Yeah, just the whatever other, like that's my terminal side, that's my terminal side, that one's my terminal side. Wherever that angle ends. And we're going to get, on the next slide, we're going to graph, not this one, but the next one. We're going to graph 3 different angles. You guys don't have to write this down, so don't worry about that. All this is saying is I can rotate around in a circle a bunch. Just like I said, the 64 game 1080 snowboarding means you rotate 3 complete circles. So here if I look, if I go from here to here, that's a 30 degree angle. We can talk about coterminal angles. I can go all the way around the circle and I could end right here. So there's 30 degrees. If I go one full circle, that's 360 plus another 30 is 390. So 30 degrees and 390 degrees they share the same angle. The same reference angle is 30 degrees. I could go another full circle. 360, 360, that's 720. And another 30. 720 and 30 is 750. That's three angles that have the same terminal side. Coterminal means that they just end in the same spot. So you have 30 degree angle. A coterminal angle could be 390. Another coterminal could be 750 for people that are funny on the test. And I think we limit it so we might actually be able to do it a little better than that. But some kids could go through and just take 15 times 360 degrees, get this giant number, and then say, well, if it's a 30 degree angle, I'm going to add 30 degrees to it. That would make me have to do a lot of math on your tests because it's the right answer. It's a coterminal angle, but I think we're going to limit it where you have to keep it between like a certain point and a certain point. But all you're doing for coterminal is you're just adding 360 degrees or subtracting 360 degrees. That's all it is. And that's why the options are limitless, and we'll get to that slide a little later. So first thing we're going to do is we're going to start by drawing some angles. And like I said, we're not going to be exact. We're not going to use protractors and compasses and make them all nice and pretty and neat. We're just going to estimate. So you got to be as close as you can. I made a third example on this one because I want to talk about that coterminal idea. It's what happens when examples in math get sick. Like when we get sick, we kind of turn green. Like we get a real pale color. The blue turns to black. It means it's got a cold. Sure. It's yeah, they can probably hear the sneezing. Can you hear the sneezing? I wonder if anybody answered. All right. No.
Yes, we can.
See? It's fun. All right. Negative 120. Let's draw the angle. So there's my quadrant. Negative means I'm going to go which direction? I'm going to go clockwise. I'm going to start by rotating downward. So are you guys okay if I don't change the color? I can just keep it. No, you're not okay, so you want me to change the color? I can leave. Okay. So there's my initial. So I'm just going to start there, and I'm going to rotate 120 degrees. Again, downward is where we're going because it's a negative 120. So if I go quarter turn, there's 90. How much farther do I have to go to get to 120? Another 30. Shh. Yeah, you have to do that little, which other one? When I talked about the negative and the pot. Are you talking here, Jordan? Okay, 225 degrees. From here to here is 180. So I got to keep going past that line. Yep, where this one is just 120. So here's 90, there's 120. And you guys have to draw in this little rotation so we know that's the direction that you went and you understand that it's a negative 120 when you do it. 400 degrees. What was that, Ennis? It's the same thing as 40. Again, you have to go through, though, and say 400 degrees. I got to go a full circle. There's 360. And then I got to go to another 40. So you have to signify that you did one full rotation and then the additional 40 degrees. Otherwise, if you just draw that terminal side in, we're just going to have to assume it's a 40-degree angle and you didn't go 400 degrees. You probably should. I don't know that we'll mark that wrong, though. So now if I come over here to 40 degrees, I'm rotating upwards. And there's my 40-degree angle. It does look different. Yeah. Went a little wide on that one. But like I said, we're not going to go through and measure with protractors. Obviously, you can't draw me this angle for a 40-degree angle. That's not 40 degrees. That's past 90. You also can't draw me this angle for a 40-degree angle. Just make sure that you're within 40. I mean, it's pretty close to halfway. It's almost a bisecting angle. So just make sure when you guys do that, you're pretty close. Any questions on drawing angles? All right. What do you notice about B and C? They're the same thing, so what do we call them when they're the same? They are coterminal. Yeah, I thought I heard it. Yeah. Coterminal. Same spot. Now what we're going to do is you're going to list coterminal angles. Find one positive and one negative angle that are coterminal with part A is a negative 100 degrees, part B is 575 degrees. How many degrees are in a circle? Yep. So that's all you're doing. Things that always help me out is drawing. I like looking at pictures to figure out what's happening. So a negative 100 degrees is right there. So I need a positive angle and a negative angle that's coterminal with a negative 100 degrees. Kiana? Let's... Yep. Position. Yep. No, you don't have. You can just... For problems like this, you can just list. Like, how would I get starting at the initial side, so starting on the x-axis, how would I get there going the positive direction? How many degrees would I have to rotate? I'd have to rotate 260. So one of my coterminal angles is 260 degrees. So we have the positive one taken care of. But I want a negative coterminal angle. Yeah. How many degrees do I have to go to here to get back to there? I got to do another 360 on top of that 100. So another negative would be a negative 460. And again, mathematically, all you're doing is 360 minus 100. That gives you 260. In our case, because we're rotating backwards, negative 100 minus 360. There's my negative 460. $575. You want to draw the angle first, or you guys just want to list two coterminals? Draw it? Okay. Well, I know I got to go 360. How many more degrees to 575? $215. So I got to add 180. Now how far is it from 180 to 215? Another 35. So I'm going to be about here maybe. So there's my 575. So if I back up 360 degrees, what would my angle be? If I take off one full rotation there, $215 degrees. Could be one of my coterminals. So that's my positive one. Now I need a negative one. So how do I go from here to there? How many degrees is that? That'd be another positive one. Yep. A negative 145 degrees. Oh, we got one positive and one negative. If you guys remember from your geometry class, we talked about complementary angles, supplementary angles. What did complementary mean? Added up to 90. What's supplementary? They add up to 180. I don't know if there's a word for add up to 360, but it's that same kind of idea. If I know that I have a 250 degree angle, I have to get to 360 degrees. So what I do is I figure out how far is it from 15 to 60. It's 45 degrees. So I'm at 260. Now I got to go another 100 degrees. So it's 145 degrees. That's just, I always add up to get to the 360. That's what I do for the math in my head. You guys can just straight subtract. You can come down here and subtract another 360, and you're going to get a negative 145. So it doesn't matter what you guys do to get it. Just come up with the two angles. And like I said, on problems like this, if we didn't put a restriction on it, you guys could just give me huge numbers and I have to go through and say, okay, well, how many full rotations do they have there? And then does it still simplify to this angle? But I think we put the restriction for that sole reason. So we don't have to worry about it. All right, last thing we got to talk about is radians. That's my definition of a radian. It's another way to measure angles. The book gives you a formal definition, and I'll talk about it with the picture that I have on the sideboard here. There's a mouse in the room, just to let you guys know. Her name's Jordan. Yeah. I didn't hear what he just said. And ignore it. All right, everybody got the definition down? Radians. It's another way to measure angles. Two things you need to know is how to convert between radians and degree. And really, you only have to know one thing, and it's just pi over 180, because you just flip it the other time. As long as you know those two things, I'm hoping that when we've talked about conversion factors in the past, you guys understand how to simplify this stuff. We did with word problems all the time. I said make sure that your unit analysis, all your units match up, where if you have miles in the numerator, you want miles in the denominator to cancel them out. In this case, you're going to look for the degrees or the pi. If I give you radians, pi is in the numerator, so you're going to use the one that has pi in the denominator. If I give you degrees, the degrees is in the numerator, so you want to use the one where the degrees is in the denominator. And all you're doing is multiplying. We'll have two examples and then we're done. To talk about what a radian is, just real quick, on a circle you have what we call a radius. It's half of the diameter. How many degrees are in a circle? 360. In trig, when we do all our base knowledge, we talk about the radius being 1, and we call it the unit circle. So if my radius is 1, what's the circumference of the circle? Formula for circumference is 2 pi r. No, 2 pi r. It would just be, if the radius is 1, 2 pi r, it'd be 2 pi. So the circumference of the circle would be 2 pi The amount of degrees in a circle is 360. If I write that as a conversion, there's 360 degrees per 2 pi. So in other words, 180 over pi, or pi over 180. That's where it comes from. In college, I got to do a neat activity where we used M&Ms and we measured the radius, and then we went around the circle to figure out how far it went, and then of course we got to eat the M&Ms at the end. But you go through, and that's some of the activities. And if you guys take trig, I don't know if they do that in there or not, but if you guys take trig next year, that might be something that you guys will do, just to talk about radians a little more in depth. For right now, I just want you guys to know pi over 180 or 180 over pi, because what we're going to do is we're going to convert 320 degrees into radians, and we're going to convert negative 5 pi over 12 radians into degrees. And like I said, this should be some of the easiest stuff that we do in this chapter, because all it is a multiplication. As long as you can cancel out your degrees or cancel out your pi, then you're good. So which conversion do I want to use if I start with 320 degrees? Pi over 180. So I'm going to always multiply. In this case, I'm going to choose the pi over 180, because if I take a look, I have degrees in the numerator, degrees in the denominator. Those are going to cancel out, and then I can start simplifying. And I'm pretty sure this is on the no calculator portion of your test, so you guys have to be able to simplify numbers. First thing you should be able to recognize is they both end in 0, so you can just cross them off. You can divide both by 10 right away. So I have 32 pi over 18. What's 32 and 18 both divisible by? 2. So I have 16 pi over 9. Is there any other numbers that divide? Nope. So you're done. 16 pi over 9. That's the same thing as 320 degrees. And if you guys remember from Monday, I said one of the first things you guys want to do when you're using your calculator is make sure you change the mode and set it to degree mode, because more than likely it's going to be easier for you to punch in degrees on your calculator than it is to punch in radians. And that would also be my suggestion. Anytime we give you radians, I would change it to degrees, because that gives you guys a better understanding of, okay, where's that located in the circle. In my high school math class, my trig class, we just had to be able to recognize, well, pi over 4, that's 45 degrees, or pi over 3, or pi over 6. We had to know all those because we did a lot of graphing. We're not going to do any of that with you guys. You're just going to get the basics, and then if you take trig next year, you'll get all the specific stuff where you'll just know it inside and out. For right now, we're just giving you some general knowledge. Help you on your ACTs, juniors. There's some basic trig ones on there. What am I going to multiply by on for the second example? Negative 5 pi over 12 times 180 over pi in this case, because I want to get rid of the pi. Usually how I do that is I eat it. I just fist pumped. You guys couldn't see that though. Pi's are gone. Can I simplify 180 and 12? Yes, I can. They're both divisible by 12. So that becomes 15. 5 times 15 is? Not all at once. 75. And then a negative times a positive? It's negative. Good. So it's a negative 75 degrees. It's the same thing as negative 5 pi over 12. And that's it. Yay. Alright, there's your assignment. It is page 780, 25 to 35, and then 37 to 59 odd.